Hello again, and welcome to the third and last day of Interactive Tooling Days. We can even believe that it's going to end today. What a journey! We have an incredible agenda for today. Sit comfortable and let Interactive Tooling Days begin. Today, we are going to discuss a topic that is gaining attention in the industry: machining superalloys and the impact that these operations have on the industry. So, it's impossible to dissociate the topic from the turning machining operation. We propose to bring it together and to understand the importance of high-resistant superalloys for the aerospace industry. Why do we believe that it's essential to highlight turning? Let's take a closer look at the facts and figures to understand the significance of turning in the cutting tools industry. The market is segmented into four main product categories: turning, milling, drilling, and other. Turning products account for the largest market share with a significant 41%. Milling products follow closely behind, accounting for 37% of the total market share. Drilling products, on the other hand, account for 11% of the market share. Lastly, the other category, which includes specialized cutting tools, account for 12% of the market share. The industry is getting more and more complex. The types of material requested for machining are more difficult to work with and demands for specific tools. We want to share this study from McKinsey that highlights the material intensity and diversity that we need when we are building a car. Let's take a closer look to the new options versus the old options. From the left to the right, HEV, hybrid vehicles, ICE, internal combustion, FCEV, fuel cell, and lastly, at the right, BEV, the battery electrical vehicles. As we can understand from this study, the complexity and density of the materials is increasing with the new options of mobility. For that reason, we should be focused on being side by side with the manufacturers to be sure that we are able to test with them the new tools and new materials. Palbit should be the first option once they start to test new materials. Let's work on that. As the new industry gets more and more complex, are new ways of work. Let's take a look at the most relevant insights, the near future of the industry. Advanced materials. The adoption of advanced materials such as composites, superalloys in various industries has led to an increased demand for cutting tools with specialized geometries, coatings, materials that can efficiently machine these challenging materials. Customization and tool specificity. The demand for customized tools and tooling solutions tailored to specific application is on the rise, driven by the need for improved performance and productivity in various industries. Additive manufacturing. The emergence of additive manufacturing, 3D printing, is creating new opportunities. Tool coatings. The development of advanced coatings such as PVD or CVD coatings has improved tool performance, wear resistance, and tool life, allowing to achieve better productivity and cost savings. High-feed milling that we have discussed in this event. High-feed milling has gained popularity due to its ability to increase material removal rates, reduce machining times, and improve tool life. And, of course, Industry 4.0 and digitalization. The cutting tools industry is embracing digitalization and Industry 4.0 technologies. Lastly, green manufacturing. The cutting tools industry is increasingly focusing on sustainable and eco-friendly manufacturing process. But how is Palbit managing the change? We want to give you some good news about this. By the end of 2023, 25 of our product boxes will be 100% recycled. This path will continue until 2025, where we'll have 100% of plastic boxes made by 100% of recycled plastic. This will be integrated in our sustainable path because We are tooling for sustainability. But let's wait no more and give the stage to Bruno Nunes, our area manager. Bruno, the stage is yours.
Hello, welcome to the interactive tooling days of Palbit. My name is Bruno Nunes and I am the area manager of Palbit responsible for the German market and the UK market. Today we will talk a little bit about turning of heat-resistant superalloys and titanium. We will see exactly what is heat-resistant superalloys, how big is the global market, and in what industries you can find more this type of materials. After this, my colleague Francisco Marques will talk you about the best geometries, grade and solutions available in Palbit to machine heat-resistant superalloys and titanium. So let's start. What is heat-resistant superalloys exactly? This is a group of materials called ISO-S according to the ISO codification that can be divided into heat-resistant superalloys and titanium. Inside of the heat-resistant superalloys, we can find basically three main groups of materials: nickel-based, iron-based, and cobalt-based materials. These materials are difficult to machine in general because they are sticky, create build-up edge, and generate a huge quantity of heat. But probably the main reason to the demanding cut on this group of materials is because they retain high strength at high temperatures. As talked before, machinability of heat-resistant superalloys is demanding and the difficulty increases according to the following sequence: iron-based materials, nickel-based materials, and cobalt-based materials, as you can see in this graphic. All these materials have high strength at high temperatures and produce segmented chips during cut, which create a high and dynamic cutting forces. Because of all these challenges, optimized tools are naturally a prerequisite, but equally important is how to apply them. In this presentation, we will guide you through the most common materials and machining applications. We aim to give you applications and process recommendations that will help you to use our products in the most productive manner with maximum component quality. But before we talk about our tools and how you should use our tools in a proper way, allow me to show you some figures about the market of heat-resistant superalloys and titanium. In this picture, you can see the global turning market size in components of heat-resistant superalloys and titanium in millions of dollars. As you can see, this is a market that will grow in next years. This year, we are talking about of more or less $1,300 million, and until 2027, this number will increase almost 8%. So, this is one of the reasons why Palbit are investing and innovate in turning solutions to machine this type of materials. Other reason for Palbit's strong investment on this in recent years is the incredible challenge that these materials present. For this reason, not all the producers are able to fulfill the requirements to entry in this type of industries. Palbit has shown in recent years that it can be a reliable supplier in turning solutions to machine this type of materials. On this slide, you can see the global turning market size per workpiece materials. In orange is well visible the slice of heat-resistant superalloys and titanium. On the left, the figures of this year, and on the right, the forecast for 2027. You can see a sustained growth in the consumption of components on these materials in the following years. Here you can see the same, but in percentage. The group of the heat-resistant superalloys and titanium represents more or less 13 to 14% of the total markets. On the left, the percentage of this year, and on the right, the forecast for 2027. In 4 years, the consumption of heat-resistant superalloys will be more or less the same as the consumption of stainless steel. Superalloys is one of a few materials that will grow in percentage in next years. Let's talk about the main industries that have the highest consumption of heat-resistant superalloys and titanium. We are talking about, for example, of aerospace, power generation, oil and gas, medical industry. And the properties of these materials which make them attractive for these industries are mainly the retention of strength and hardness at high temperatures and corrosion resistance that is important, for example, for the oil and gas industry. As we saw in previous slide, the main industry for these workpiece materials is aerospace, medical, oil and gas, power generation, and we can add also defense military industry. Here you can see the global annual purchase amount in millions of dollars by end user in these different industries. On the left, the figures of this year, and on the right, you can see the forecasts for 2027. Here you can see a growth in all these main industries that uses mainly this type of materials, the superalloys. On this slide you can see the same, but in percentage. On the left, the percentage for this year, and on the right, the forecast for 2027. These 5 main industries for heat-resistant superalloys and titanium, aerospace, oil and gas, power generation, defense and military, combined represents more or less 25% of the total market. So it's a big market that we can and should explore together. In next minutes, my colleague Francisco will show you all the solutions that Palbit can offer you for machining this challenge to cut materials. But allow me a last words to tell you that in recent years, Palbit has invested heavily in tools capable of high performance and high productivity on machining of heat-resistant superalloys and titanium. Our firm commitment is to continue to invest in this area and lead the market in the coming years. Together with you, Palbit will shape the future of the heat-resistant superalloys. Thank you and see you soon.
Hey, I'm Francisco. I'm an application engineer at Palbit, and I'd like to take over from Bruno now and maybe get a little into why these superalloys are so difficult to machine, and also what are some of the solutions that Palbit has come up with to try and mitigate some of the problems they bring about. So Bruno made a little introduction into these materials and their machinability, but just to bear down on it a little more, so what makes them so difficult to work with? First off, they're usually pretty strong and pretty hard as well. But maybe they're not the hardest or strongest materials you work with, but what makes them special is the fact that they retain those abilities even at high temperatures. So you can't really expect that as you turn, as the workpiece heats up, the material gets softer. This doesn't really happen with these kinds of alloys. Now, furthermore, they're also really poor heat conductors. This poor conductivity by itself may not seem like such a big issue, but in fact, the processes of removing metal and creating chip are always going to generate a lot of heat. And as usually you would expect your chip to carry away that temperature, but this doesn't really happen. All of that heat is going to be trapped at the cutting point, and this is going to cause Subsequent issues such as chip adhesion and built-up edge, which severely hampers your tool life, and crater wear as well. Now, furthermore, usually they are made hard, these alloys, either by the inclusion of carbides or very hard precipitates. So essentially, turning them is almost like turning into a grinding wheel. You are slowly chipping away at your insert. Lastly, they also have the tendency for work hardening. The issue with this is maybe your first few passes are not a big problem, but eventually, as you increase the amount of force you're putting on your workpiece, you're going to start running into much harder material. So we at Palbit came up with kind of a three-way approach to improve performance when turning these materials. On the one hand, for a brand new chip breaker design, which we will apply on standard shaped inserts. We additionally went for a completely new insert concept, new shape, and we topped it all off with a brand new PVD coating. So first off, this new chip breaker design, how it works, why does it work so well? Well, we introduced a larger rake angle than usual, which we hope will decrease your cutting forces and reduce the heat generation. And we paired that with a sharp cutting edge, which should give you a lighter cutting action and decrease that work hardening effect. Now additionally, as I mentioned, these are negative inserts. And negative inserts have the advantage of allowing you to keep a larger cutting edge and therefore make that edge a lot more robust. Furthermore, the chip breaker design itself is also a bit different, as these alloys usually create serrated chips, which are a little different from the continuous curling chips you might find on steels, for example. Of course, we pair this up with our brand new PHH coating, which significantly improves tool life. This chip breaker is applied on all standard ISO shapes, like your rhomboids, your C's, D's, and V's, but also square and triangular inserts as well. Now, for a test report, we try to compare our GS chip breaker insert with the PHH coating against the competitor equivalents on turning Inconel 625. In this, we saw an impressive 60% improvement in tool life. Now, additionally, we also introduced a brand new concept for an insert, which we've been calling DOMX. Now, as some background information, as you probably know, tool holders with small entering angles, usually in the 60 or 45 degree range, cause an interesting phenomenon known as chip thinning. This chip thinning allows for higher feeds, which translates into much higher productivity. However, these same tool holders also make use of either square or triangular inserts, which are positioned in such a way that access to the workpiece is restricted, especially when you are trying to turn up to a shoulder. Now, this forces you to have more tools and more tool changes in your programs, which lowers your productivity. So with this in mind, we try to come up with a way to combine both the small entering angle concept and its advantages with a tool that allowed for greater access and versatility. Out of this combination, we arrived at DOMX. Essentially, DOMX is like a DNMG style insert, and it mounts at the standard 93-degree entering angle tool holder. However, it has a special cutting edge profile that enables it to cut at a 45-degree entering angle. This way, we combine the best of both solutions. DOMX cuts like a square insert, but improves your access to the workpiece, especially when you're turning up to that shoulder. The smaller surface contact also reduces heat generation and cutting forces. And you can still use high depths of cuts and feeds. In short, DOMX combines high feed capabilities with minimal sacrifices to accessibility. And even though the special profile of the insert is asymmetrical, they are still negative and double-sided. You just have to choose between left-handed and right-handed inserts. The chip breaker itself is designed with the same considerations in mind as the GS inserts, and it's also paired with our brand new PHH coating. Again, in a test report, we found remarkable tool life improvements when turning Inconel 625, this time up to 140%. Lastly, a new PVD coating was also developed. This thin, single-layer coating boasts great heat resistance thanks to its high silicon content. This allows it to withstand the temperatures you might encounter when turning super alloys. The coating is usually paired with one of two hard metal substrates, either as PHH 910, the harder of the two, and the first choice for turning these materials, or PHH 920, a tougher grade, more suitable for interrupted cutting. Even by itself, this coating already improves tool life considerably. In testing, we found increases of more than 30% when turning Inconel 718. But we're still adding new items to our superalloy solutions. Soon you can expect to find the new GSF chip breaker, specially designed for finishing operations. We increased the rake angle and created a special cutting-edge chip, which we paired with a redesigned chip breaker. Furthermore, these negative inserts will be provided with a 0.2 mm corner radius, making them ideal for finishing. This is all I have for you today. It was just a quick overview of this subject, but I hope you find it useful anyways. If you need any recommendations or have any further questions about turning these materials or any other, please let us know. Thank you, and I hope to hear from you soon.
For decades, aerospace has been an industry defined by growth. There have been crises over the years, but never one so deep and heavy as COVID-19. Now that the markets have returned to the levels of growth of the past, how can aerospace manufacturers get back on track? The answer lies in a more sustainable manufacturing. Projections estimate the industry will be back to where it was pre-crisis even in the next 2 to 3 years. And Palbit is well positioned to lead this recovery. During this presentation, we will show you all the tools and solutions that Palbit developed in last years for the aerospace industry. But before we talk about our solutions and how you should use our tools in a proper way, allow me to show you some figures about the market of aerospace. This is the global annual purchase of cutting tools amount by end user in different industries in millions of dollars. On this slide are the main industries, and as you can see in blue, the aerospace industry is an important part of the market. On the left, you can see the figures of this year, and on the right, you can see the forecast for 2027. On this slide, you can see the same thing, but in percentage. The aerospace industry represents 6 to 7% of the total market. On the left, the percentage of this year, and on the right, the forecast for 2027. A percentage of 7%, it may not seem so much, but there are few producers that reach the prerequisites of the aerospace industry, and Palbit is one of them. The aerospace industry has the challenge in the incoming years through this weight, noise, emissions, and have a higher efficiency with lower consumption. There are different ways of approaching all these challenges. Alternative fuels is one of them. New engine types is other possible solution for these challenges. Palbit is aware of these changes and challenges in the aerospace industry, and in recent years has invested heavily in solutions capable of reliable performance and high productivity in aerospace industry. As you will see in next minutes with my colleague Francisco. Together with you, Palbit will fly in the wings of change and will shape the future of aerospace industry. Thank you and see you soon.
So, the following overview is just that, an overview, but it should paint a broad picture of the kind of solutions Palbit offers when turning heat-resistant superalloys. So these alloys, when used in the aerospace sector, are mostly applied to engine components, which are required to withstand very high temperatures. Common parts include blisks, fan discs, and shafts. Now, generally speaking, the OMX is, of course, your ideal choice for roughing passes. That's thanks to its ability to perform even at high feed rates. However, for more general turning and, depending on surface finish requirements, even finishing operations, a standard negative insert with a GS chip breaker and a PHH coating would be our first choice. Of course, Palbit also offers a very wide range of PCBN inserts, which could be an interesting alternative. This very, very hard material may allow you to run your finishing passes at a much higher speed than carbide. Lastly, Palbit also offers that same GS chip breaker in an RC MT insert. Round inserts can be a great solution when turning these very difficult to machine materials. If you have a good grip on CAM software, you can implement some very interesting trochoidal turning strategies. In these, you are dipping the insert in and out of the cut, never letting the temperature rise too much, and you're turning the tool holder around to distribute the wear across the edge much more evenly. Of course, if you have any suggestions about or any questions about specific applications, feel free to ask us, of course. That's all I have for you today, but thank you.
Thank you, thank you, thank you. Interactive Tooling Days ended, but we believe that it was an incredible journey that we built together. As always, this couldn't be done without you, your support and partnership. We are confident that it's the beginning of a new journey for Palbit, where Palbit is providing more tools to support the partners. Let's stay connected, because we are tooling for you.